Hi, so this is a small tutorial on essentially how to solve quiz number 3 for the 1220 Chem Recitation. So, with this problem, we are given the information that at body temperature, 37 degrees C, the solubility of N2 or nitrogen gas in water in contact with air at typical atmospheric pressure, 1 atmosphere, is 0.015 grams per liter. Air is approximately 78 mole percent nitrogen gas. So, in summation of what you have to do in this problem, essentially what you are trying to do is first find out the amount of nitrogen gas you're dealing with, and then see essentially what will happen if a diver were to start here at 100 feet in water. What would happen if they suddenly surfaced? What would happen to the nitrogen gas? How much of it would bubble out of their bloodstream from going from 100 feet to 0 feet in water? So first, in part A, we calculate the number of moles of nitrogen gas dissolved per liter of blood, and we assume that blood is more or less an aqueous solution. So we start off here, if I may direct your attention here. Solubility of nitrogen gas, again, is 0.015 grams per liter. To get from this to a molar solubility, all we need to do is multiply this number, or rather divide this number by the molar mass of nitrogen gas, which is 28.01 grams. And so from here, we simply get the molar solubility number, which is 5.355 times 10 to the negative fourth moles per liter. So now that we have that, we move on to B, at which we try to figure out at the depth of 100 feet in water, pressure is 4 atmospheres. What is the solubility of nitrogen gas from air in blood at this pressure? So from here, we know Henry's law, which is essentially the solubility of the gas is equal to a constant times partial pressure of said gas. What I want to bring out and what I want to illustrate is the fact that we can treat this sort of how we treat mathematically the gas laws. And so essentially what I have shown here is that if we simply divide both sides of the equation by the constant K and partial pressure of the gas, we can find that that ratio equals 1. And all ratios will equal each other, such that you can essentially have the solubility at 0 feet divided by the constant times the pressure, the partial pressure at 0 feet, equivalent to that expression at the 100 feet condition. So what are we trying to look for here again? We're trying to look for the solubility of N2 at 4 atmospheres, essentially. So we can take out the constants here and solve for the solubility at 100 feet. So what in essence you need to realize here is that solubility is proportional to the partial pressure in Henry's law, such that what's happening between 0 feet and 100 feet is that your pressure is increasing, your total pressure is increasing from 1 atmosphere to 4 atmospheres. Thus you have a 4-fold increase in pressure. Well, since your mole fraction isn't really changing, this means that likewise the partial pressure of nitrogen is increasing by 4-fold. And so if you look here, essentially P at 100 feet is 4 times P at 0 feet. And so if you divide those, you'll get that this is essentially 4. P over P 100 divided by P0 is 4. So 4 times, so S 100 equals 4 times the solubility at 0 feet. which ends up being 2.1 times 10 to the negative third moles per liter of nitrogen gas. All right, so we have that for part B. So then it asks the final part, so if the scuba diver dives to 100 feet and then suddenly surfaces, how many milliliters of nitrogen gas in the form of tiny bubbles are released into the bloodstream from each liter of blood? So, from here, the way we want to think about this is that we have two solubilities. We have the solubility at 0 feet of nitrogen gas, and we have the solubility of nitrogen gas at 100 feet. So this essentially is telling us how many moles per liter, how many moles of nitrogen gas per liter blood is soluble. And so what you will notice is that essentially you have higher solubility of nitrogen gas here than at 0 feet. Thus, the difference is what will bubble out of the blood, or into the blood rather. So essentially all you need to do, considering a liter of blood, is subtract the difference in solubility, which in essence, if you set 1 liter of blood, you're just subtracting the number of moles that are actually soluble. And your difference is the number of moles that all of a sudden bubble into the bloodstream. And so from here you get 1.607 times 10 to the negative third moles per liter. Again, this is a condition that per liter you have this many moles of nitrogen gas that are bubbling out. So what are we ultimately looking for? We're looking for milliliters of nitrogen gas, but we technically have moles per liter. So it's saying per liter, how many milliliters will be nitrogen gas, all right? So we use the ideal gas law here. We solve it for volume. Volume is what we need. And we plug in accordingly. Per liter, we have that many moles of nitrogen gas times the temperature at 37 degrees, which is 310 Kelvin. Divide that by 1 atmosphere, which is the pressure at 0 feet. And then multiply that times the gas constant R, which will lead you to 0.041 liters or 41 milliliters of nitrogen gas that will bubble out per liter of blood. So thank you for watching. I hope this helps you understand the quiz 3 question. Thank you.